distance.
Yeah. Yes.
Exactly. That's so good.
That's perfect.
Yeah.
The last name's like so
Yeah. And it's delivered in it's called Phair after.
Yeah.
Started the recording.
You started it?
Yeah, it's great. Yeah. It's on. Yeah.
Oh, let me check.
Oh, we'll wait a few more minutes.
Yeah.
Paul?
You want to get into it? After work?
Oh, I can't wait.
At least drop tomorrow or next week. I think I will. I'm sorry. I'm thinking about you. There's something
I imagine.
没没做很多，我现在想法就把这个然后咱们一会儿把那个开始真需要问什么？先要争取。 先这样还干完了以后再下面。 如果好的话，我看是不是应该发在那个。我就是相信10万和30万，那是真的。对，可能会找人，我也自己也是。对，像你说那个外包人应该是。对，现在就说。我觉得有一个像那个就是微观的对公众有心不让宣传。
How's it going?
What?
It's fine.
我在如果你要不会有隐忍。所以我觉得这个比较卡住了。对啊，对。对，因为癌病主要是地域的问题，因为你不知道那个是或者你的任何的第一个我想的是我看这个format 是这样。就是这样。对，弄一个。哦，对对对，就是这个，它的不一样，对，一个是旁边来的，对，啊有，
You is from Drake.
Fun, fun. Yeah.
We're going apples to apples. Yeah.
Right. Yeah, yeah. Yeah. How it goes for you? Yeah, it was 12:30. I just went to class.
哦，有 scenario， 那你之前
Actually, yeah. There was silence too. Questions about how hopeful, how we helpful.
right, so we're getting going. Well, welcome to CMT. For those of you who don't know me, my name's Ian Cross, Director of CMT. This is the second of a series of talks that we planned this year. Last one we did was on neuromarketing, forms around data analytics, particularly in the retail space. And we're planning to do monthly events next year as well. Hopefully, this is the flags these days, hopefully culminating in an end of year April event all around business of retail and possibly luxury as well. So we're very lucky today to introduce you to Matt Phair and Chaitanya Prasanna from Ahold Delhaize. And I'll let them explain a little bit more who they are. They're well known to me as, I'm going to say European, but maybe not European for very much longer. But if you've ever wondered what happens when you go in Stop and Shop or Hannaford's and swipe your card as a loyalty customer, these guys are going to scare the pants off you about what they actually do with all that information on the mag strip on your card. So hopefully you're ready to listen and learn. Ask as many questions as you like. We've got a very thoughtfully put together presentation, which is really in a couple of parts. Those that are generally interested, and then those that are very interested getting down into coding, and I'll let these guys talk about this. But before I do, I just want to introduce Alex Rodovich. Alex works with me here in CMT, and we wouldn't have this event here today if it wasn't for Alex. So I want to hand over to Alex just to explain her involvement and why this thought to be a great event.
Okay. So I had the really great experience of doing a summer internship at the data science team over this year with Ahold Delhaize. And I got to work with both Chaitanya and Matt and really loved the experience of getting to do data science projects that were fun, that were one-offs, so they got to be creative. We got to delve into a lot of different models. And I thought this was a really great way to show people what doing data science for marketing looks like when it's all you could hope for. So I wanted to share it with the Bentley community. Thank you for coming.
Yeah, thank you for having us. This is so exciting. Right now, coming into finals, this many people are still interested to come hear us talk for a couple hours about data science. So that is definitely glad to be here and glad to have you guys there. So we'll just kick things off. So we are here representing the Ahold Delhaize data science team. My name is Matt Phair, like I said. I am the manager of data science within Diplo, which is our digital personalization, loyalty, and analytics department based here in the US, supporting our subsidiaries here. So really what I say our mission is we're trying to build products and conduct research that feels like a crystal ball to our business partners and to our subsidiaries. Because when we can come back with a prediction that's really accurate, or we can come back with a recommendation that if you do this, there's this probability of this outcome, that really is kind of where our department starts to bring some magic into the business. So I focus a lot on building hyper-personalization, which is kind of catering the most personalized experience to each one of our customers. So no two customers interacting with our business should have the same experience if we are doing our due diligence and understanding that customer and providing a service for them. And beyond that, we are, as we'll get into a little bit more, we're putting in a lot of work to start to use data science to drive a data-driven learning culture within the organization. So moving people away from kind of the heuristics, I've been in the industry 20 years, so I think we should do this, and moving more into the, well, what does the science say that we should do?
All right, thank you, Matt. I'm Chaitanya Prasanna. As introduced before, I am currently a grad student at the University of Pittsburgh myself, and I'm part of the Ahold Delhaize Diplo's co-op program. So right now, my work primarily focuses on understanding customers' purchasing behaviors and performing new segmentation strategy for 4 Ahold Delhaize branch, being Stop and Shop, Hannaford, Giant Foods and Giant Martins. Before that, I used to live in India, where I have a background in computer engineering and social work. And if data science becomes completely automated and I'm out of a job, I have a backup career as a yoga instructor.
As most data scientists.
As most data scientists do. But yeah, it's been fantastic to having just working at Ahold Delhaize, working under Matt. It's a fantastic experience, and we hope to share some of that with you guys tonight.
And he's got a way better intro picture. I just couldn't confuse myself.
Somebody said that's the best Bollywood picture of the night. It's, again, nothing compared to Shah Rukh Khan, right? But yes, so Matt is going to talk a little bit about what Ahold Delhaize as an organization is in America and across the world.
All right, so before today, just by a show of hands, has anybody here heard of Ahold Delhaize before or familiar with the company? You are, right?
Actually, I met a recruiter from our career fair.
Oh, okay.
I think this March.
Oh, all right, very cool, very cool. So we have one out of this group, and that's not uncommon, and actually to some extent is by design. So even though Ahold Delhaize is one of the largest retail companies, our strategy is to be a holding company for a lot of localized brands. So if I say who here is familiar with Peapod or Stop and Shop or Hannaford or Giant or Food Lion, depending on what areas of the country you're familiar with, then a lot of people start to be familiar with our brands. But there's actually a lot that goes into the company. So we are a Dutch retail holding company. So we have 21 companies. We're in 11 countries, mostly in the US and around Europe. We've got just under 400,000 employees and a little over $70 billion US of revenue annually. So we are kind of a huge company. And here in the US, we are like one of the top largest supply chains on the East Coast. So there's plenty of data for us to analyze. So that said, we are actually, our team, which was put together earlier this year, is the first US-based data science team that we have. So after a lot of effort and work, we finally were able to sell the case that instead of having data science just living in Amsterdam and in Brussels, we should also have data science here supporting the US banners kind of on the ground in the US. And they went for it. So now we are trying to get together a team really quickly and start being able to add some value with data science. And what makes that both challenging and really exciting is that we're coming into a company where we have so many terabytes of data historically. We have every click that anybody's ever made on any of our websites. We have interactions with the apps. We have every product that's ever been sold, when it was sold, what register it was sold at, for tens of millions of customers. So we are kind of for the first time really taking the initiative to get all of this data organized and start adding some value both to the business and also to the customer experience using that. And as we are doing that, there is a lot of catch up to do against some of our competition, and we realize that. But we also need to balance that with doing the cool, fun stuff. So our strategy really is we're split sort of 50-50 between projects to get us caught up with what some other industries or some competitors are doing really well, but also building our own new innovative data science tools and building new algorithms and kind of pushing us forward with that. And so with that, we are pushing really, really hard to start staffing up, getting more people on. So we're looking heavily for a data scientist. We want computer scientists, data engineers, but we also need reporting analysts. We need people who maybe have some basic SQL skills, but aren't the developer who wants to sit down and write 500 lines of code every week. So yes, there will definitely be plenty of job postings onto our team going forward.
So we get started with part one of our presentation today, which focuses primarily on the non-technical aspects of trying to incorporate data science into business and the organization. What here we're going to talk about is as Matt said before, trying to play catch up with the competition, which is already disrupting the industry in a huge, huge way. So it's a lot of it really depends on legacy companies trying to sort of modernize themselves in terms of incorporating a data-driven learning culture. So what is the need for data science in the modern retail industry? Of course, first is, as I said before, the legacy retail business model is in decline. We see huge companies like Sears and Toys R Us, for many reasons, go out of business, but primarily because what used to work in the past a few decades ago is not really the case today. And that primarily happens because progress in e-commerce coupled with just being able to couple with challenges and changes in purchasing behavior of customers. The way we shop today is not the way we used to shop 10 years ago. That really sort of incorporates the idea of why the modern retail industry needs to change, like the legacy companies need to change. Another thing is the one-size-fits-all rule doesn't quite apply to customers anymore. Customers expect more, they expect personalization, they expect to see if you get personalized feeds on Facebook and Instagram, it's not too much to ask for a personalized feed on when you're going out to buy groceries, for example, be it on the shelves, do whatever works with whatever works when you're buying something. If you say you buy beer, you want bread next to it. That's like the biggest sort of association rule that people talk about, right? And so to compete with the disruption in the industry, retailers must utilize the data science capabilities that we have. We have terabytes and terabytes of data, and now we have the ability to utilize that data to make something off of it and make strategic decisions that can drive our business. So why should MBAs and marketers care about this? First is the fact that data scientists
You never found out who was in the crowd.
Oh yes, I think it's a good time to do that. So
Skip a step.
oh, not bad. So just by a show of hands, who here has an experience of any sort?
That's fantastic. That's not unexpected. That's good. And within like data science languages or Python, those types of tools, it's like the same hands. That's awesome.
That's awesome. Right. So why we ask that question is data scientists and business leaders speak two very different languages, right? This causes sort of organizational frustration, which we deal with almost on a day-to-day basis sometimes. And as you see here on the chart that we made of sorts, most MBAs have high business acumen, but technical ability is sometimes lacking, and it's the opposite of that is in the case for most data scientists. And what we're looking for is people in the upper first quadrant, where people have the business acumen as well as the technical knowledge to bring together the business decisions and the ability to use data science and data-driven decision making. So what data, just moving on with that, we can't provide value without data scientists who understand business, and the other way around too. So our best business partners, for example, understand basic applied statistics and the scientific method and how that drives decision making. So how the gap is bridged is, at the end of the day, the customer is who we want to cater to using these data-driven decisions. So we need data scientists, of course, to have a better direction in understanding the business needs and make solutions to that end. We also need business partners to come together and have better decision making, to come together and use those tools that we made to push them to the leadership to make sure that the right tools are implemented in the right ways to help the customers. And finally, one of the most important ones is the IT infrastructure, is to productionize all the work that we've done and take it to the customer or implement it within the organization itself. And Matt will talk more about how these three come together in some of the projects that we're working on.
So just a kind of a sample of the projects we're working with right now that are either already bringing a lot of value to the business or will when we get them productionized and working live. Right now we have a really big initiative to forecast individual people's behavior change. So we apply some unsupervised machine learning to take all of our customers and find customers who behave very similarly. So we kind of divide them into homogeneous groups, and then we take all these data points that we have about them and feed them into more machine learning. So those data points may be the frequency that you shop, the type of products that you buy, when you shop, how many coupons you use, how you interact with our website, whether you use the app more or you use the website more. And after we've collected all of these data points, we can start to get really powerful profiles and predictive models looking at rates of change and be able to say, this customer here has been decreasing their engagement for this amount of time. So in the past, when we had customers behave that way, when we intervened by offering them one of their favorite products very steeply discounted, that kind of pulled them back. That created them to change their behavior. And we have enough data now to be able to do that really effectively. So we can do a lot of individual influencing of our customers, which, I mean, ultimately is providing a lot better experience for the customer too, because that means that we're providing them with enough value that they are choosing us over a competitor, increasing our share of wallet of that customer. We put a lot of work into developing causal inference tools. So I'm sure nobody here is familiar or is a stranger to the saying that correlation is not causality. Well, we need to be able to establish causality. So we work a lot within that field of mathematics and experiment design to be able to say, when we step in and do X, Y, and Z, this is the outcome. But that's not enough for us because we work in a very messy world. We can't design a perfect experiment. So we need to be able to parse out the impact of multiple inputs on customer behavior, on sales, on a lot of these different metrics that we're working with. So we've developed we put a lot of work into developing causal inference tools so that we can identify what elements of campaigns, contact strategies, and strategy decisions that we've made in the past were effective. We also are implementing algorithms live on our website. So when you click onto a product, everyone here is familiar with customers who bought this product also bought this product. But we want to take that a step further because if you buy lemons, that doesn't mean you're likely to buy an avocado. But if you buy lemons and limes and onions and jalapenos and garlic, that means you're very likely to buy an avocado. So if we can take everything that is in somebody's basket and make these real-time suggestions, say, hey, did you forget this product? Or customers who buy this product usually also buy this product. That can start really adding value to the interaction because it makes people get their whole shop the first time. And it also kind of introduces serendipity, which is, for example, through working with these, I found out that people add garlic to guacamole, for example. I never knew that was the thing. I don't put garlic in my guacamole, but I want to try it now that I found out that a lot of people do. And then finally, developing a multi-purpose recommender engine is a big initiative right now. So we want to be able to say, not just given your current like what's in your basket right now, you should also look at these products. We want to be able to say, this is how you have, like looking at how you behave, looking at how other customers like you have behaved. We think that you would really like this product, or we think that this offer is really relevant to you. And so we need a kind of a class of algorithms that works to not only recommend products, but also recommend offers, and then take that a step further to recommend contact strategies. So are you most likely to want to be contacted through an app or through a text, like an SMS or through an email? And are you more likely to forget that you've had that contact if we go through one of those paths? So this one here is another one that's bringing a lot of value into the organization kind of immediately to get that developed. All right, so that's kind of the end of the very high-level overview of what we are doing, kind of from that non-technical angle. So at this point, any questions? Yeah.
I'm just curious, do you think recommendation engines or just recommendations in general, do you think sometimes if people are grouped, individuals are grouped with, say, others in the wrong way, do you think recommendations can have like a negative impact on the user experience? Like, let's say sometimes, like you were open to like garlic used in guacamole, but let's say, like, do you think sometimes when people are grouped together with others and their preferences really don't match in any way with the user, do you think that can have problems? That can cause problems?
Yeah. So that's something that we need to put a lot of work into to make sure that we're not making those mistakes. Because really what it's getting to is relevancy. Are we putting a bunch of stuff in front of a customer that's not relevant? From the same way that you get targeted ads when you use Facebook or YouTube. I mean, at some point, if they're just breaking down, it's frustrating that none of this makes sense. So we do need to put a lot of care into that. And to do that, we do take a couple different approaches. So we're not grouping customers and saying that this group of customers all gets these products and these targeted whatever. It's actually at an individual basis. But it says that say you and I, for the last year, we have very, very similar shopping behavior. And with the data that we have in millions of customers, we can start to find really close lookalikes. But say I always buy raw almond butter, and you have never bought raw almond butter, but you buy almost the same everything else. Then we're able to identify that, hey, maybe you'll like this, and we can put it in front of you, and then we can record the response. So, did you like that? Did you start purchasing it after we introduced you to this product? So yes, there's definitely a fine line that you need to walk through being too aggressive and piloting new algorithms and potentially losing relevancy. Because when you lose relevancy and the customer feels like they're getting an incorrectly personalized experience, then we definitely run the risk of decreasing that customer's engagement with us. Yeah.
So, so you make like a couple dozen purchases at first, you buy like a certain amount of products, and then like suddenly you decide to make like a lifestyle change and like go totally the opposite way. How responsive would the algorithm be to those kind of changes? Like,
yeah, so that's definitely a good question. So what you would be likely to see is maybe in the first week or so after this huge lifestyle change, the recommendations are going to be totally wrong.
Yeah.
Because they're going to be recommending for who you were, not who you are now. But you kind of think as time goes on, we're taking sort of rolling chunks of time, then they should get more and more accurate as time goes on because they're learning more and more accurately what your new shopping behavior is. And so you're giving more weight to the way that you're shopping now than to the way that you shopped a year ago.
Yeah.
So yeah,
would it be kind of like a Markov chain thing, or I don't know, that kind of like.
So we do use Markov chains. Well, actually, you're walking through a model a little bit later that uses Markov chains.
Right.
But we don't use that in our recommend direction.
Okay, gotcha.
Yeah. But I mean, there's definitely a lot of opportunity to do that, but we don't care.
I noticed some recommendation engines start to have some kind of AI element where they ask customers whether they like it or interested in this, and you can actually tell them not interested, then they wouldn't do the same thing. And they keep giving things, and as you respond, they start to know, like getting better in there. Is that some element in your algorithm?
Yeah, so that is kind of a holy grail for being able to do this. Now, we do not have that. A big part of the reason is the strategy and kind of the dynamic of this industry. So, for example, if you are, say you're a shopping company, say you're Nordstrom or something like that, you have a lot narrower product offering, and people purchase less often. So, if you send somebody 2, 3, 4 advertisements, that makes sense. But a lot of times, depending on the campaign, somebody might get 20 things from us, and then it's a real quick skim and say, yeah, I get this, and this, and then the price is taken off when they go to the register. So it would be a lot more, asked from the customer to give us that feedback. But you do bring up a really good point, because right now we assume we were wrong if the customer didn't do or accept whatever we sent to them. and we assume we were right if they did. But we don't know, maybe they were on vacation that week. So yeah, what you're saying would be great for a feedback loop. Take this one.
Yeah.
So I understand accuracy is important in these models. So do you also involve the concern of profit and loss function? Like maybe prioritize some more profitable products instead of equally treat all the products to promote?
So that works in separate ways because on one end, recommendation, of course, we want to serve the customers what we give, but it also, to a certain degree, serves as a monetization strategy. Because if you're shopping in store, what goes where in shelves is something that also works with, is something that companies can pay for to put their products up on like the face house, so you don't have to look down for like a good pasta sauce that you're looking for. So right now we don't employ that, but of course, recommending say a certain brand, if you're for example, if our association rules or if our recommender engine is going to recommend pasta sauce to you, which pasta sauce gets recommended, if it's like say basil pesto, which basil pesto will get recommended ends up being a monetization strategy. But we also evaluate our accuracy based on if that recommendation was actually used by the customer, and that is how we sort of analyze it in terms of if that generated sales, if that made the customer change their behavior or just increase their share of wallet with us. These are sort of the metrics that we use to analyze and sort of see, and that's how we're just going to get into next, how we use data science in campaigns, and that's how we sort of drive our data-driven learning culture.
Yeah. Perfect. So I think I might jump to the next part, just in the sake of time right now.
Yep. Right. So we talked in the first part about how we use data science in just driving data-driven learning culture, and recommendation engine and stuff. But another place where we can use it is, of course, data science is based in campaign strategy. How we can run short-term or long-term campaigns but in a data-driven way. Now, in an industry like grocery retail, campaigns are running throughout the year and tens and tens of campaigns running at any given point in time. And for a company like Ahold Delhaize, which works with different brands, different campaigns running on different parts of even the eastern seaboard of the United States, that's a lot of data that is being generated, and it would almost be a sin not to learn from the outcome of those campaigns and design better campaigns as we go ahead. And that's something that our competition does anyway. So, we're sort of taking our own grave if they're not doing that. So, our campaigns are generally designed with a few objectives in mind, of course. Now, this is the legacy way the campaigns are designed anyway. And these objectives can be taken and sort of fed in our sort of data-driven culture. First is to increase the incremental sales, which is to increase the sales and then sustain that. Next is to incentivize customers to shop with our brand rather than with competition. That is the share of wallet that I just talked about. Another is retaining customers and preventing churn. And finally, rewards and loyalty targeting. So where is the data science? Data science's largest role in this aspect is for experiment design, to make sure that we're controlling we have our test and control groups and the target control audience. At the same time, making sure that we are continuously refining the nature of our campaigns as we go ahead. So we also have, of course, some constraints when we work with this. The first thing in offer targeting is to identifying what metrics is to see what these constraints are, right? So the models which offers the customers most likely to respond to the data that we feed into our model is the customer's past behavior, the customer's similarity to other customers, and the similarity of their favorite products to other products that they might be interested in eventually. And when we do that, we also have to program to make sure that our models meet our budget constraints, the total number of offers that we give to customers. So we don't want to give too many offers to a customer and not have that customer at the end of the day contribute to our sales. And the total value, and so the number and the total offer value to the customer. So be that in percentage or in dollar amount. So how all these things work is Matt will explain that in the next slide in the, sort of the campaign targeting engine that we've been working on.
So I hope this flowchart doesn't get too busy, but I think it does a really good job explaining. So we built this from the beginning before we even built a recommender engine. We wanted to lay out exactly what we needed to consider, and sort of just some way to have it represented to keep us focused as we built this. And so you can see really step by step what it does is it scores customers to products or customers to offers. I guess we're talking about campaigns now, so this would be offers. But so, for example, maybe you have an offer for a type of mustard or for a type of cheese. Every person will get a score to every product, saying how relevant it is to them for that objective. Then it goes into kind of optimization. Are people here familiar with linear programming, constrained optimization? Yeah. So it goes into an algorithm with that. So basically, it tries to maximize the score per person while constraining for things like budget and strategy elements. So the scoring model, that input, like we said, it takes the history of the customer and the products that they like. It compares them to other customers, and then it compares the products that they like to other products. Then we feed over here kind of what do we want to optimize within this. Are we trying to sort of stretch the engagement of a customer who we feel has a high probability of becoming a more engaged customer than they are? Or are we trying to reward a customer who is already a great customer and we want to keep it that way? We have things like engagement. So we designed, for one of our companies, we started a new program a while back, and we found out that we weren't capturing as much of their holiday shop as we expected. So we had a lot of loyal customers and a lot of customers who were really engaged with the company, but for some reason we were missing out on their holiday shop. So our mission for that, it wasn't to stretch, reward customers, it wasn't to increase the amount of sales that we get. That was just to get them, hey, come to our stores instead of the competitor for this next holiday. And then incremental sales is kind of just the term that we use for sales lift. Like how much sales did we make over what we would have made had we not done this. Then we feed in, the budget, some of the constraints we were talking about, like the total amount of value that a customer can get. Because if we don't do this, we'll have our top customer get $500 worth of offers this month. Or like, hey, this customer is not an engaged customer, so don't give them anything, we don't care about that. So we constrain it to make sure that even though the best solution might be those things, make sure you find the best solution while constraining for these. And then at the output of all of this, we end up with a target file, which is the results from every customer and then every offer that customer should receive. And from there, offer delivery is a team separate from us, and it doesn't really have to do with data science, but I think that it's important to understand the full sort of life cycle of how campaigns work. And we definitely could not do our jobs if it wasn't for them. They're sort of the conduit between us and the business, and they take that targeting file that comes out of the model, and they're the ones who set up everything in our system. They make it live, so when you walk into a store, that amount of money comes off. It shows up in the app, it shows up on the website, an email, or whatever the targeting medium is. They're really the ones who handle all of that.
And so at the end of it, when the campaign is over, we have all the results, how many redemptions were made on the particular access, how many customers were engaged. Once we have all that data, we look at some KPIs, which are top line sales lift, customer behavior change, and the ROI that we had on the entire campaign. And since this, we can have a very high level, or we can do a deep dive into it based on like the size of the campaign and what we really want from it. But then what we do work in, and this is where the main part of our work comes in, is to identify and isolate the factors that impacted the campaign and the way we wanted it to work. So what worked and why did it work, and to what effect did it work, and what didn't work and why it didn't work. And this is where a lot of our work comes into play. And through this, data science continuously improves a lot of the campaigns. So when we're designing our next campaign, we can learn from the mistakes. We can try maximizing or minimizing the factors that we isolated and identified, and design better campaigns, see how that works, and establish causality to a certain degree. And of course, at the same time, designing better campaigns for our customers. And so everything that we explain sort of is a continuous process, right? It's not, so it keeps going round and round. So we, because also of the nature of our company, we have different brands. So what we learn from the campaign of one brand, we really see does this work for another brand too. So this is why working with the business, targeting and control, formulating the campaign, delivering it to a company, analyzing it, learning, and the whole cycle keeps going on. And that is sort of the ideal data-driven learning culture that we are establishing at Ahold Delhaize. So does anybody have any questions about this at this point? Yes.
I was curious. When you were creating that campaign targeting engine, I believe it was called, right? Did that conflict or the clash between what the business leader wants and what the data scientists do and want, did that kind of come to the fore? Did that surface?
So actually, that happens all the time. But with this one, it actually wasn't that bad. And the reason being, before any campaign, we're meeting with the brand. We're meeting with the decision makers to design the campaign, and we make some suggestions about strategy. But by the time it gets to the actual targeting portion of it, we know exactly what offers are available to be targeted. We know exactly what constraints they have and what strategy there is. So the business's input really comes into, so on that flowchart, it really comes into the constraints.
Right.
So they say, we want, there have been times where they change their initial idea, and we've just run this model overnight, and then we need to go back and try to rework it. But so they'll say something like, hey, we want to give out $10 of value to everyone, or as close to $10 without going over. Or they'll say, hey, everybody gets 8 offers, things like that. But by the time it gets to this point, we are pretty much all on the same page, portion of it.
I came in a little bit late, so if I'm asking something that you went over, I apologize. But you mentioned towards the end of this that, after a campaign is over, you'll go ahead and analyze the variables that were responsible for the success of the campaign. What's your process for doing that? Is it statistical analysis? Do you have control groups? How do you measure the impact of the different variables? And how do you tease that out?
So we try to work, it's not an ideal situation, but yes, we do a statistical analysis to see, based on the KPIs, how we've done in that particular campaign. We try to keep control groups, but again, since in the nature of having working across so many brands and so many customers, it doesn't always end up happening. And so that's why in the earlier part of the presentation, we talked about how sometimes we need to design sort of experiments and mathematically find causal inference in some cases that a control group might not be present, to the best of our abilities to be able to make those inferences. But most of the work that we do is sort of seeing what the numbers are and performing statistical analysis on how things performed and trying to establish causality in that.
Thank you.
So generally, just a quick follow-up on that. So generally what we'll do is if it's something that really we are working with the business to design, we'll make sure that they have a stratified control group. If that's not possible for whatever constraints, then usually we will at least try to have it in a way where we can do some propensity score matching to really be able to at least assign a post-hoc control group. And a little later in the presentation, we'll go into how we go about approximating the impact of these things when we don't have a control group. But obviously from a mathematical standpoint or a scientific standpoint, that's kind of the worst position to be in. So we try to avoid that.
So maybe Mr. Samuel on chat, but to what extent do you use this data to create segments of customers and then map them to customer journeys?
So this here, we might take what offers somebody has redeemed, But this year is separate work from the customer journey. Actually, Chaitanya kind of magnum opus for the company so far has been the customer journey. So.
Yeah, so a lot of the segmentation strategies that we work with is to see, just segment based on different criteria. So we have just monetary segmentation, which is essentially how much the customer is spending with us, based on which we have primary, secondaries, tertiaries, and based on their recency, frequency. We also have their engagements. We also have engagement in terms of how much they're redeeming. Are they actively redeeming the rewards that they're earning? Or are they just getting discounts like everybody else would that to buy something off the shelf? And that, of course, is we keep a historical record to the best of our ability, and we see the most recent segment. We try to predict segment migration as we, based on what the current shopping behavior is, or like a rolling shopping behavior in the past quarter or the past few months, and to be able to sort of see where the customer is right now, what has led to them being there, and what we can do to move them up a segment or keep them where they are.
Your segments are spend based.
Not all of them, but my work currently is working on spend-based segments. We have different segments based on what we do. So we might have like subgroups. So it's a primary customer who is highly engaged. So it's a primary customer who also uses a lot of the rewards. So it could be a primary customer low engaged, just spending a lot of money, but not really caring what if they earn rewards or not really caring what discount costs. Maybe they don't have to, but so that is what we sort of segment our.
So say like, I just want to be left alone. Like I just want to go into the store, buy what I need. I don't want my data being collected. Can I opt out?
Oh yeah, because you don't need to be part of any of these programs to shop.
Oh really?
Yeah. You don't need this. This is we're not Cambridge Analytica. Yeah, this is for the this is just for people who want these personalized.
Oh, I see. Okay,
gotcha.
I just want to add to his comment that I live really close to Stop and Shop.
Mm-hmm.
Every time I shop there, they request the card. Otherwise, I have to pay higher price.
Mm-hmm.
So for customers, I think it's not really optional if they want to save money.
Mm-hmm.
So they have to scan the card.
Oh yeah. So that is true. I mean, that's kind of the core of any loyalty program. I mean, so with Starbucks, anything like that, you get deals on what you do as kind of the trade-off for being in the program. Honestly, I am kind of new to Boston. I can't speak that well to exactly what Stop and Shop does, but I can speak to what some of our other companies do. And they all have their localized strategy. So some go very hard for the high-low pricing. So here's the standard pricing, which should still be competitive, but here is the pricing if you're in our program. Two, we have other companies. So for example, Hannaford, which is not in Boston but in the area, their whole strategy is never have two-tier pricing. Like you get incentives, you get rewards if you're part of the company. And yes, they'll ask you if you want to scan your phone when you walk through the register, but there'll never be a change in prices. But yeah, that's
I was curious also internally, what are you doing to manage the data, to document it, to make sure that only the right people get a hold of it?
We have so much security that our hands are tied behind our back for half of the stuff we want to do.
Yeah.
Which I guess for a lot of reasons is a good thing. But so we have entire security teams, and then all access is provisioned through an infrastructure team that really manages everything within Iron Fist. So yeah, there's a lot of that. A lot of it doesn't happen on our team specifically. Yeah, we need to go through like VPNs, Citrix gateways, and need like the amulet and the secret code to get into the data. So, and so you go ahead.
I was just curious, does like an aggregation to anonymize data happen at certain levels for certain people?
Basically, you are in a position where you have access to customer data or you're not.
Okay.
So a lot of people who are analysts or need to do some sort of analysis need to be able to analyze what's going on in the store and how many types of products are sold, stuff like that. But we don't want them having any access to customer data. So yeah, there's a very small number of people who have access to customer data, and then that is not.
And most of the work is done by matching keys, which is essentially the card number, and that is a non-customer. On top of that, we almost never have access to the personal information. That is something. So, yeah. Sometimes it happens that we don't get stuff that we're supposed to get. So that's frustrating sometimes, but
Yeah. I'm sorry, we've kept you waiting for a while.
So early on, we talked about that you were interested in data engineers, data scientists, and analysts.
Mm-hmm.
Can you describe those positions and what you're looking for people that might be interested in applying?
Oh yeah, absolutely. So we're actually we're going to walk through a little bit more of this in a bit. But yeah, I mean the very high level. So for data scientists, that's a very coding heavy job. So we use interchangeably R and Python. So you need to be pretty well skilled in that. A good understanding of kind of classical applied statistics, applied science, a good understanding of modern machine learning frameworks, preferably in both R or Python, but we use them interchangeably depending on what project we're doing and kind of strategic purposes. You need to be pretty well skilled in SQL. Generally familiar with being able to call APIs and whatnot to be able to get the data all in one place. So that I would say is, the very high level of what a data scientist does. The data engineers that we work with, mostly entirely in SQL. So they're the ones who are actually developing our databases and kind of giving us schemas and putting best practices into our data to be the most efficient. There is going forward, we're going to be leveraging Spark more, so potentially some understanding of solid coding, basic distributed computing understanding.
This is for the engineer?
For the data engineer, yes. So those people, what their work looks like is we need to get analysis done really quickly, and we need it from all these different data sources, and we don't have a query built for it. We all work with SQL pretty regularly, but we're by no means data engineers. So it's a lot better to have this one person who really lives in the data and has a lot of skills, so we can say, here's exactly what we need, can you go write this 200-line SQL query for us? The analyst roles, it's a lot of visualization, some lightly applied statistics, maybe some hypothesis testing and regression and whatnot. Generally, there is coding involved with that because we are moving data from different areas, but it's not the crux of the job that you're doing. That's a lot of data analysis and being able to automate processes to kind of provide dashboards and whatnot, so that the business really has their thumb on the pulse of what's going on with whatever they're trying to measure. So I would say that's kind of the highest level, and then computer scientists are just not so much working with the code. They're doing a lot of our infrastructure development. They're taking a lot of algorithms that we build and productionizing them, making them more efficient, finding ways to parallelize them in our cloud environments.
One more question?
Yeah.
Do your data scientists need to understand Spark? Environment?
I would say they need to have a general understanding of what's going on in distributed computing. But the way that we call Spark, we call it through binding. So we use SparklyR or PySpark or something like that. So generally, they don't need to know Scala coding. That's your question. But a general understanding of how data goes in, how data comes out, and kind of being familiar with MLlib would be really important.
Perfect. Thanks.
And sorry, in terms of machine learning, do you use TensorFlow or PyTorch or?
Yeah. So generally for machine learning, still most of what I would say 90% of it is using Carrot and R right now. We use Python pretty heavily.
Yeah.
Honestly, I love Python, but a lot of times with machine learning, just the documentation and whatnot isn't quite there as well. So there are great frameworks. We will use
like
Jupyter, like our recommender engine is all built in Python. I would love to get more into that. I mean, especially for kind of the back-propagated type algorithms. Python's definitely doing some really, really interesting stuff right now. But currently, I'd say we do machine learning in Python, but mostly it's scikit-learn or other libraries. Yeah, I think so. So just in case someone had to run in here and miss some pizza, and before we put anyone to sleep there, we figured we'll call maybe a 10, 15-minute break. Just a quick overview of the way that we've structured this. So the first half, we weren't sure exactly who the audience was going to be. So the first half, we kind of kept it non-technical sort of strategy, explaining sort of data science's role within the organization. And for the second half, we're going to kind of focus a little bit more heavily on the technical. So types of models we work with, how we're implementing these projects, and then at the very end, we're going to just walk through a couple of coding demonstrations. So we will not be offended if anybody's not interested in the technical half yet.
All right, so take 10-minute breaks, there's drinks and pizza over there, and then we'll get going again. Thank you.
How you doing? Working in digital marketing. That's very relevant to some of the work that we're doing. I teach an IT 101 class. In the class. Even the marketing department or math department. Yeah, well, marketing, there was a time when I started with it in that. Yeah, well, the analytics really does larger and larger part of managing nowadays. Purchase a lot of media on social networks. A lot of it is pressing buttons and the algorithm takes over. Even the whole concept of communication.
But I definitely don't.
So that's actually super. We got an entire slide on that. But you know, I've also
I don't want to
right.
Exactly. I know, yeah.
All the time. I mean, there's some of the terminology they were throwing out. I have, of course, care about what. Well, especially as science and math. I'm trying to stay away.
So we're
been about it for a while. Pretty not be too nervous. That's what the first slide. Yeah, you know, after that, kind of settled in, I think.
So it's a great technology, but I would say it's not a barrier to it is.
Just made it seem like that's where it's one of the nice perhaps, but it's not. In school, you get CSV.
Yeah, I mean, at the high school, so I started in data science class also. So I was in session. I'm saying hands-on what's important. Like, from my experience, Even if it's super great internship, but you're going to be learning more about but yeah, we definitely do that. But if I were to go back and start again, I think what I would do is I would learn one language in my course really well. I would argue it's more important to know, like, you can really manipulate it, do statistics of Python, but you don't know anything about that's still, I don't but as long as you got that, that's more important.
Yeah.
You teaching me something?
Get a semester, and then I can study at a very high. Very.
Oh yeah.
There you go. This is a fun
Yeah.
Yeah.
So we have
That'd be great.
Because I mean, the data analytics undergraduate degree is, I think, in its first year right now. So there isn't a lot like that industry, like mostly finance and accounting, so they have very like strong connections with in that sense. But I feel like for someone who's trying to get into data science at our point, it's a lot. You have to. It's like the emphasis is on you to like go out and find those companies.
Yeah, absolutely. But even we've got a reporting branch. Even coming into something like that, that's lightly technical. You're using data, but you're really kind of learning the industry and you're beside data scientists.
I think that's
something like that. I think would be really good. Yeah.
And you're in the same spot as the other.
So I guess they're not like.
Oh yeah, no, for sure.
Yeah, you were saying like the most important thing is to be there, working with someone who has that experience.
All right, great.
All these classes are actually what do you think I finish my business major?
Really? I still need one more class. I just need an 8 a.m. No, I can't do it. Because I'm in one right now and it's my
Yeah, a little bit.
I probably won't be able to do it here.
Yeah, I mean, it's interesting. So.
That sounds kind of sick.
I do a couple minors decided this couldn't be too sections.
And then when you buy it, that money comes off.
I didn't
So
know
we see the Kelvin, and then we see the numbers actually. But you are right. That's usually kind of a dead zone.
But
no.
We have like pages on there. We did
Oh yes, we do get that.
And also
Well, yeah, maybe the way So sorry.
No, actually, I'm looking.
No, that's a good question.
Yeah, sure.
Yes.
Oh.
What are you doing? Are you going or are you
Are you
staying?
doing your finals?
Good luck.
It's like one of the fastest growing jobs right now.
Are you going for in spring?
It's there's not enough people to
Maybe I'll come and help you. Chatty, you and me. No, this is my
Yeah, I would say that's Good to see you. Yeah.
This is great. Come back from the 13th.
Yeah, I think so. I think I might have to go to Yeah, okay. I'm looking forward to it. Yeah, no problem. I guess I probably should have sent it to you earlier. It's not too late. All right, good. Oh yeah, media, which came from the production a while ago. What that? Yeah, right. It's not there anymore. So that should be pretty exciting. Really kind of. Yeah, I mean they have a nice program because we have to spend like $250,000 a month. So Suzlon is one of their resellers. But
They always
get on for that.
They always
they have a hybrid program where they serve.
They always say
Almost like a trainer.
never ask how to
optimize a sounding board. So for a couple months, you can use it. And they charge, I don't know, and then once you get comfortable with it, so whereas most of the other programmatic providers want to kind of, they want so yeah, I like that.
It's like guilty, right?
Yeah, no,
I'm listening like this when Mike's months like
that's common. That's common in that space.
I didn't think it was.
No, it had nothing to do with you.
Yeah, I
think you might have actually.
It's like
that's what happens. People change.
I think let me see what the rest like this
agency business. I never worked for one, but I always had had an entire agency. And I used to feel bad for them, because they'd be getting last minute change, working on the weekend.
I never felt bad. I always felt I didn't mention the
Yeah, they do. John Hancock.
Yeah, you know, I what am I?
Yeah, that's what we use. Yeah, that's with that Fleet Bank.
Oh, so it's good.
Yeah. We said it will rub off. Yeah, yeah. Well, Wayne, same thing.
So at 7:30, then you go on the 7:30.
Yeah, they're there anymore. Is that where they are?
Cut it. Not cut it. They just.
All right.
Yeah, break it in half and then they.
I'm gonna try. I'll see how long I can do. May not be too long. We'll see. See how far the part comes around. Yeah, well, I'll see you. I'll see you in a week or so. Yeah.
Algorithm is just always structure needs to
About to have very different weight.
Yeah. But just like
Especially like I don't know.
I know, I broke down also. It's hard. That's why I managed to stick with one also, but I'm on the way out. What's happening?
I'm hoping someone takes it away.
No, I mean,
It's sort of like, yeah. I don't know what it is. A combination of cheese, sauce, and stuff. My 20s, I probably have paddle meat.
So I've never.
Which math class do you
But another thing is that you have to
I want you in the nothing bad. It's not like, I mean, he's just literally does tax. So,
Is that class mostly statistical or no?
Learning is using. Nobody knew the top one until C. Don't worry about just help my buddy.
Hey, I'm making things
So you had to doing that.
I want to do that. It's literally Are views like literally just, and then you have to make them, and then you just sort of more freely. So like, it's like creating a table of like a query table. Yeah, it doesn't look that bad, but
Now it's, I don't know if it's popular, but
and it's
Typical.
It just takes that one time.
that one time.
it's an effort to find out what's next.
Oh yeah, so actually,
that like was
that's unnecessary. You don't have to, but it's like
you figure you know where it is.
yeah.
I'm sure you'll be totally understanding what they're saying. Whereas I'll be struggling to understand what
Like I said before, whether you're a scientist or analyst, it's still you go all the way to that.
All right.
That's what makes it.
Yeah.
Hopefully everybody likes pizza. That's a free pizza. I'm actually on to the rest, so we need to hang around to stick through the technical part.
I'm
That's good. That's good.
You're super hard. Over here.
All right, so we've got the rest of this is going to be the technical part of what we do, and we're breaking this into kind of two parts where we do an overview of the work that we do, and then at the end we're going to show you two pretty cool models that we work with that we've talked about a little bit, but we'll actually take them and we'll walk through them, code them out, and you guys can see the outputs. Because I think both of them are super cool, and I think they'll be helpful for you guys if you're pursuing a career with this. So to kick it off, what is a day in the life of a data scientist? You guys might recognize Alex from this. This was Alex's going away party when she left our team. We're dining party. We had a bunch of retirement decorations in the office. Put them to good use. But so a daily the daily flow involves a lot of coffee. We have free coffee at the office. We stay very caffeinated for most of the day. The structure of our work is generally, most of it's project work. So there's not a lot of, here's a task, do it, here's a task, do it. A lot of it is being able to be good consultants, meet with our business partners, meet with the people in our subsidiaries, and have discussions, identify what their pain points are. And then it's on us to figure out how can data science be used to fix that problem. There's a lot of that. There's a lot of the company asking us to do something for them, or asking us if a certain type of experiment might be possible. There's that, and then also a lot of just building things that we're interested in. We thought it would be a really great tool to develop an app that kind of the non-technical users could upload their data, do clustering, see segment migration and whatnot. And so myself, Chaitanya, and Alex spent a lot of time in this room here with music playing, and we built an app and kind of put it out there. So when we're not doing that, we watch a lot of YouTube. When we're not doing that, we automate a lot of our analytical processes. So how do we get the data from our database to be insights that's in front of our business partners? Because anything that can be automated should be automated. Then we do some ad hoc research. A lot of times people are like, what is going on? These numbers don't make sense. We dig into the data, we figure out why customers are behaving a certain way, or why sales patterns are going in a certain way. And then we go back for more coffee and we start the process. So some of the cooler models that we work with, we just threw out our go-to models, things that if we need to be doing solving certain problems, these are ones we heavily rely on. So we use Bayesian structural time series models a lot. We'll get into that a little bit later, but that's one of our coding demonstrations. We use gradient boosting quite a bit, whether that be GBM or XGBoost, some distribution of gradient boosting. We use a priori, which is how we find and do the product association rules we were discussing earlier. And then we work with collaborative filtering in our recommender engines. The first one on the list here, the Bayesian structural time series. Is anybody familiar with this model? Because it's kind of a beast, and there's definitely a bit of a learning curve. But we'll show you how it can be implemented pretty easily. Yeah.
Does it have anything to do with naive Bayes?
It doesn't. So naive Bayes is generally for classification, but this here is kind of a time series model. So it does work with approximating a prior and posterior probability. So it uses like MCMCs, like the Markov chains, the Monte Carlo Markov chains, to get to that point. But mostly it's in how do you understand different states and how they impact whatever response variable you're working with. So we use this for forecasting and nowcasting. And the reason we do that is so that we can isolate the impact of any of the variables on an outcome. So for example, if we want to know the impact of, well, what we're going to get into is the impact of inflation on sales, the impact of cost changes on sales, then it's really easy to add those states in there and control for them in this model. And then measure what the impact of each of those controls is. Then kind of already alluded to this, but you can programmatically add states to the model to be able to kind of get a little bit deeper understanding of this. So within this, what about this term here? We've said it a couple of times. Are people here familiar with the field of causal inference and what that type of model does? So basically, causal inference is to understand not just correlational relationships, but to understand when one thing causes another thing. So a lot of causal inference, if you think of applied science in a lab, you've got, I think it's usually taught, you've got rats that are receiving a certain type of cancer drug, and the other rats get a placebo. You probably don't give rats a placebo, but you get the idea. And then to understand that it's not correlational, you have a control group, and then you measure the response between the control and the trial group. That's the most basic example of causal inference, trying to understand this caused this, and not just these are correlated and increase and decrease at the same rate. So the way that we use this is we say there was an event. Say it was a marketing campaign that nobody told us about, so we weren't involved in the experiment design, which sadly happens. So no control group, and they want to get their best approximation of what would have happened. We use this approach called nowcasting, which essentially is predicting the present or predicting something in the past, and then trying to get a prediction of what would have happened without an intervention. And the magic of that, I'm sure some of you have taken some forecasting, some time series courses. When you think about that, the big issue in being able to do that type of forecasting is you don't know what the impact of any, or the value of any impacting variable is. So if you're trying to impact sales, you might really be able to predict what sales are going to be when there's a snowstorm, but you don't know if you're trying to predict sales for next week if there's going to be a snowstorm. So essentially, we're taking all of these factors and we nowcast what would have happened if there was no intervention. Then we compare what happened to the actuals, and we take a Bayesian approach to being able to understand what the probability of us seeing the actuals differ from the forecast by this much, given no intervention. So essentially, it's a hypothesis test at the end. Just with some fancy terminology thrown in there. All
All right. Next, one of our sort of go-to models for predictions and classifications is a gradient boosting model. Now, anyone here aware of what linear regression is? Of course. So, if a linear regression was like at early 2000s, then gradient boosting is an Apache helicopter in terms of being able to get things done. So, what it is essentially is a composite model that combines efforts of multiple weak models. In most cases, those end up being the single trees to come together and create a stronger model. What it wants to do is what we want to do with it is to reduce the mean square error and to give weightage to outputs that give a higher error. So we minimize that in every iteration that we do. Now, the mean square error, of course, is the L2 error. In some cases, and we run into this quite often, is that we can't remove outliers. Outliers are part of the data, and without them, the data is they're just very important to the analysis that we're doing. In such cases, instead of the mean square error, you work with the mean absolute error. Right now, of course, the mathematics of gradient boosting will probably take up time till 6. If we get into it, it involves a lot of applied calculus and just a bunch of stuff, which you should really get at par on if you want to go into an interview. Yeah. But what the final part of it is, why all this sort of comes into play is the model at the end of it wants to form a gradient descent to train all these small weak models iteratively to come to a stronger model which helps make a better decision. Either you can use it for classification or regression based on what your problem is, of course. So it's one of those models which works across both the spectrum of machine learning. And so this is something that we go to. This is something that we went to in being able to predict customer behavior in the next segment. When I say segment, it's in the next period, my bad. So we tried a bunch of models. We tried support vectors. We tried different types of regression or tool lasso, stuff like that. But the problem that we always almost ran into was that we weren't getting results that we were getting a lot of misclassification. So our confusion matrix wasn't looking as well as we liked it to. And to top that off, our balanced accuracy was somewhere around 63, 64%. And we plug this into this baby, and we come out with 88%, and that's much more than we required. But yeah, so this is sort of ended up becoming a go-to model for many of the problems that we're trying to solve.
What was the acceptable threshold?
So we are looking for something around 80, because of course anything can happen in that period for the customer to behave the way we don't expect them to. But if we got up to 80%. Correctly, that was good enough for us because we just have enough customers to be able to be sure enough in making that call. Matt's going to talk about the next model that we use for association.
For the last model, what was the typical sample size?
For this, for that, so we use it across different brands, but generally the sample size was 1 million customers and their data across. Last 4 quarters.
4 quarters, yeah. Almost a year.
Yeah.
And so, just on that one, has anybody here worked with any distributions of gradient boosting before? You have. Which ones?
XG boosting.
Ah, very cool. What is it?
We were trying to predict who is more likely to get heart attack.
Okay. All right. It's a fun model to work with.
Yeah,
it's insane how accurate it is.
But we found out that actually for imbalanced data set, XG boosting doesn't work that well. I mean,
imbalance is in one, so low prevalence of certain outcomes.
Yeah, so if the positive case is around 2% of the overall data set, then we need to do some pre-processing before we apply the model.
Yeah. So yeah, that's a common issue with kind of any of the iterative models. General approaches are. Okay.
You tried different types of sampling approaches.
Yes, so we ended up using some sampling methods for it.
Yeah, but I actually don't know about XGBoost, but with other GBM implementations, you can penalize errors for certain ones. So that's another way of not changing the sample distribution. But yeah, for anyone who hasn't worked with that, it's there's some really great distributions of it that make it super easy to work with. It's really powerful. Now, what about, none of my statistics or data science classes ever talking about this algorithm. Is anybody familiar with a priori? Really? All right, so clearly Bentley teaches students better. So for those of you who aren't, a priori is used for association rule mining. So when one thing is present, is another thing present. And our immediate use case for this is when we look at transactions. So people's shopping baskets. When one product is present, is there another product present? So we were talking earlier about live on our website being able to say, we've got these things in your cart. You've got these things in your cart, so you should also buy this. Now the three kind of key metrics you work with when you work with this are support, confidence, and lift. And the reason that you need these are, so support is easy. It's just the percentage of transactions in that an item occurs in. So very obscure, I mean, we've got hundreds of thousands of products, so very obscure items do get sold. And sometimes we still need to be able to find association rules for obscure items. So a lot of times we'll find something with low support that might be like a fraction of a percent, but for the person who buys that all the time, that's an important item for them. And in over 100,000 items, it's very easy to be that small fraction. So to take that one step further, we go into confidence, whereas confidence really starts to give us the ability to make recommendations. So what is the probability of Y given X? So you can think here, this graphic brought to you by Angry Orchard. The probability of beer existing in a basket that has an apple. You can think of that as the percentage of transactions that contain both of them divided by the percentage of transactions that contain just the apple. So one of the really cool things with a priori is it's not machine learning, it's not a black box, it's nothing iterative, you don't have to set a seed to run it. It's really just somewhat simple arithmetic and like a good scanning algorithm to be able to identify this. But here at the confidence level, we can't truly use this. So just a fun retail question. Does anybody know any American grocery store what the top selling product is going to be?
Eggs?
It's actually, it's bananas. In the US, it's always bananas. It doesn't matter what company you are, what store you are, it's always bananas. So if we just take this approach, we'll say, okay, somebody has cat food in their basket, so recommend bananas. Okay, this person has engine oil in their basket, so recommend bananas. So that really doesn't give us the power to be able to make strong predictions here. So then if you look at the probability of Y given X while controlling for the prevalence of Y, that is where the magic starts to happen. And it's really, I mean, again, it's just pretty simple arithmetic that brings us a lot of really strong predictive power into our recommendations.
All right, so before we start talking about collaborative filtering, which is another way of making recommendations by seeing customers and items, we need some goals to find what recommendations, like we need to set some criteria on what are the quality of recommendations that we're bringing to our customers. First is, of course, it has to be personalized, relevant to the user. It also has to be diverse. You know, you can't be, it's no point if we only make recommendations to a certain customer in, say, dairy. God forbid they don't want to be vegan. But, and then, of course, so we want to give them a diverse range of options from, it helps us sell more products, it makes sure, we also make sure that we're increasing customer share of wallet at the end. It does not recommend products that the customer already knows or would have found anyway, something that frequently the customer has a tendency to buy frequently. And finally, the cherry on top, as Matt talked about before, is the serendipity, sort of the unsought finding something that the customer did not know they wanted, but then wanted it once they saw it. So collaborative filtering works in this. Essentially, it's a two-dimensional problem. You have customers and you have items, and you sort of have to find what works with what item works with customers and the other way around. So there's two approaches we take. We take user-based collaborative filtering, which is making a recommendation based on the similarity of the users. So our focus here is, as you see here, we have a target user. So of course, for the lack of a better example, this is in terms of movies. So in our target user has rated I would say Mickey Blue Eyes 4 stars, and for some reason Star Trek movie 2 stars. So what we want to do is this kind of a new user. We want to give recommendations to them to watch, say, other movies. Well, the first approach that we do is we find the not K nearest neighbors, the K most similar users to that user. How that is done essentially is by seeing has anybody else rated the same movies that they have, or has anybody else rated the same movies in the same degree that they have. So we see these people have rated the same movie as them and have rated more. So the next step in this process is to calculate a similarity score between the user and between the target user and similar users. Once we do the similarity score in terms of a Pearson similarity or a cosine similarity, just whichever works better, you have to experimentally sort of figure out which is the better approach, which works better. But to start off, you can use any of those, of course. Once you have that, you can predict this user's affinity to other movies by predicting in a ballpark of how they would have rated the other movies that they've not watched, but similar users have. Now, and the same process is also done in item-based collaborative filtering, but instead of setting a target user and finding similar users, we find a target item and do it on the other dimension. Now, there's a particular reason why item-based collaborative filtering works better than user-based collaborative filtering. Not that the predictions are better in any way, but from an organizational standpoint, can anybody try taking a stab at why that is the case? Okay, so user behavior is dynamic, right? People will change the shopping patterns again and again. People will, the similarity of this person might not be the same to these 3 people in a week's time. So when we're trying to, now imagine this matrix through hundreds of thousands of products and millions of customers. The similarity matrix that we work with is something that will always keep changing. To change that on a user-based level, it's difficult to implement. But we at this point, we're still using user-based collaborative filtering, but item-based is something that sort of works well on a larger scale, of course. So that keeps updating more and more, whereas in item-based collaborative filtering, you have the items that are much more static compared to the users, and that sort of gives, from a computational standpoint, it is easier to work with. And another way to sort of work with the computation and how we manage to do user-based collaborative filtering while working with the dynamic nature of users is by involving clustering in this. We sort of put them up in segments to make sure that we're not maintaining huge matrices rather than seeing people in the same, sort of doing collaborative filtering in the same segment. That sort of helps us match customers. So if somebody is a customer who's less frequent shopper comes in like once a week, there's no point in having them in the same matrix as somebody who comes in every day, and so on and so forth.
Ask a question about that?
Yeah.
So you do different filtering depending on the cluster that the users fall in?
So we do the same algorithm, but we're sort of applying them through different.
Right, so you have different groups that you apply.
Different groups, yes.
Okay.
So just like stratify that to make sure that it's computationally easy to sort of work. So yeah, anything else?
Is it a similar recommendation system used by Netflix?
Yeah, but they use like huge. They use much more.
They've got more than we do.
Yeah.
And also one thing that's an interesting nuance to the way that we do this work versus Netflix. Netflix kind of gets it, has it easy.
Yeah.
People watch a movie and then they either finish it or they don't, or they give it a certain star count, and then that gives them a lot of information to work with. We don't have, hey, this person thinks this is a 5-star product and this person thinks this is a 4-star product. We only have their behavior. We don't have any of their feedback. So that So we need to approximate that depending on how commonly somebody purchases the product, other types of products that they purchase.
And
So is this the first way usually applied in marketing, and the second one item focused usually for like inventory planning, strategy planning, because it's focused on items?
So we don't really use recommendation systems in inventory planning at this point.
No, we don't.
We do use forecasting for inventories to make sure that what we're displaying on the website is something that we actually have in our warehouses, and to sort of make sure that no order goes unfulfilled. So we don't really use that at this point. But yes, we do use recommendation systems more in terms of offer targeting than which is indirectly marketing. Yes.
The way that we handle that is if there's going to be a large-scale campaign that's really going to impact inventory, that's something that is collaborated with our logistics and supply chain. So it's not that's already known before we get to the recommender engine, because we know what we have to target, and they don't care how we target it. They just want to know how many offers are going out and how many people are likely to buy products, so that they don't leave our shelves.
So the next slide, Matt's going to talk about we're going to have a demonstration about some of the algorithms that we talked about, but Matt's going to talk about what the qualities of data scientists that Ahold Delhaize work.
Yeah. All right. So the first thing I want to know is who here. I mean, obviously you stay for the technical part, so you guys are kind of interested in data science. But what types of tracks are you looking to go into? Like, how many of you are interested in going into marketing data science? So, like, a couple of potential. All right. With just any branch of data science? Okay. Like analytics? Okay, all right, perfect. What about this corner? What fields are you interested in going into?
Data visualization.
I'm sorry?
Data visualization.
Oh, okay, all right. So more sort of on the analytics and reporting side where visualization falls into. All right, perfect. All right, just want to make sure I'm not talking to the entirely wrong audience. So for those of you who are looking to go into data science, from interviewing a lot of people, I've started to notice just some areas where sometimes people coming out of grad school are not prepared to go into the field. And even going into data visualization, I think knowledge of these things will be helpful. The first one is classical statistics. A lot of people, I realize, go into data science without a background in statistics and mathematics. And they go right into, well, here's how you do gradient boosting in Python. And they do that in a class framework where they're given, hey, here's this CSV of data that's perfectly formatted with all your features on it. Just plug it into like XGBoost and run your model. But that doesn't give you the skills you need to really be able to understand the experiment design and what's going on under the hood. So when I'm interviewing people, I always check and make sure they can speak to classical statistics. So the theory, why do different distributions exist? Why does the central limit theorem work? Just a general understanding of that. Then inferential statistics, getting into hypothesis tests, ANOVAs, different types of tests to say, does this thing equal this thing? And then getting into predictive. So forecasting, your basic regression models, knowledges of understanding what types of models do what. The difference between a linear or a logistic regression and a linear regression. Then an understanding of machine learning, which is really kind of where data science is, it seems to be breaking off from the classical statistics as far as its applied sciences. Like, what's the difference between like bootstrapped aggregation and backpropagation and bagging, the different approaches to implementing machine learning? Understanding of feature engineering and selection, understanding of what hyperparameters are, how you tune them, best practices, cross-validation, what that's used for, how to implement it. Then another kind of category that we check off for interviewing people is understanding of applied science. So we spoke a little bit about causal inference earlier, but also just general, like, how does the, how is the scientific method applied? Because that really is the fundamental. If you don't understand how the scientific method's applied, you really can have all the deep knowledge of these things here, and you will not be able to do something meaningful with it. Then just understanding of what compounding is, what variables might be confounding, and how to test for that. Yes?
So to what extent do you use experimental design, and how do you use it? Is it like also like a model-based experiments, or?
Yeah, I'm sorry, what type of experiments?
Model-based, like you have like prediction and you want to test whether that was accurate or not. Like what kind of experimental design did you guys?
Yeah, exactly. So, that's a good question. So, say we're trying to pilot something. So, for example, when we said that new program wasn't getting as many shoppers to come in for the holidays as we expected, there's a lot of experiment design that went into that. So, we have different sort of methods that we can use to provide value to those customers. So, how do we assign control groups that are going to be actually representative of the customers? And then how can we effectively split test the other options that we have and still be able to get statistical significance out of that? So that's one case kind of where it's a perfect scenario for us, because we see it from design to completion and we do measurement. Other times for experiment design is what's a good example? Say somebody calls us and they say, hey, last week across the entire company, we just decided we made a mistake and we gave away a ton of free gas. That was a good one. Yeah. So we have gas stations. I got that call. They're like, we just gave away $2 million worth of gas accidentally. Accidentally, yeah. So they're like, we want to know if that changed people's behavior. So at that point, we don't have access to, we weren't designing that experiment. Go, hey, it'd be fun to give away $2 million worth of free gas and then see what people do. So for that, we don't have any control groups selected. We haven't really designed it in a lab, so to speak. But we need to understand good applied science techniques to be able to learn what we can from that event. So I would say that's the type of stuff that we get into experiment design with. Then there is stuff like A/B testing for website designs, for different features and whatnot. But the majority is that, trying to understand when we do this design. Then finally, all of this is made possible in the world of data science by computer science. So I would say you probably need to know one scripting language well. So if somebody is coming in for an interview and like we said, we use R and we use Python, but say they only know Python and don't know anything about R, or vice versa, they only know R, don't know anything about Python. That's fine, because it shows us that they understand the concepts and that they have a tool that if we give them a project, they can solve the project with that tool. So SQL, in any job, I mean, even in all the data visualization, you really can't escape SQL right now. You need to have some way to interact with your data and get your data in the shape that you want it to be in. And then, then yeah, just in computer, like machine learning frameworks, kind of the visualization frameworks, whether it's ggplot, plotly, shiny, matplotlib, and then the business acumen. So earlier we talked about what the business people do to annoy the data scientists. If you don't have this here, you will be the data scientist that annoys the business people. So I'd say that these are also very important to have some grounding. Now I see we've got 10 minutes left. So here, well, I'll see what you guys want us to focus on more. So we have some kind of sample interview questions that we noticed a lot of people made mistakes on. So we figured it might be useful to throw those out to the audience and kind of discuss. Then we also have some coding demonstrations for how we actually implement some of these models. So you can see the BSTS model and the a priori model. So we've got 10 minutes. I would say both of them are going to take 10, maybe 10 minutes to get through. Do people have a preference over what we get into?
You can start with question.
All right. All right, sounds good. Or maybe what we can do is we can try to take 5 minutes to do a couple questions, then we can go through this real quick. Sure. And then, I mean, we'll, I don't know if we're getting kicked out of here, but we can always speak with you guys for a little bit afterwards. Oh, that's fine. All right, perfect. So we just kind of, we're starting sort of a little bit more basic and then building off that. The first one, how do you handle categorical variables in a linear regression model? Getting to the statistic part of this. So, anyone?
You code dummy variables?
Yes, exactly. So the way that you need to do that is for every change in a categorical variable, you need either
A binary 0 or 1.
What's that?
A binary 0 and 1?
Yes, exactly. So when this category is present. So for example, if we are trying to predict someone's sales based on the number of units that they purchased and what month it is, then we would need the data formatted as sales as a numeric variable, units as a numeric variable, and then we would need a 1. But we would have basically a March column, and we would have a 1 every time it's March. Then we would have an April column and a 1 every time it's April. And then we would run one regression for each change in those dummy variables.
The next one is, and anyone, it's very funny how we get this wrong. How do we avoid overfitting?
Add more variables?
That would lead to overfitting.
Yeah, that'll make you more likely to.
Use validation data.
What's that?
Validation.
Yeah. Yep. She's
What kind of validation? It's like an incomplete answer.
You need to select the
50%.
point where validation error and the training error, like go like that.
Mm-hmm.
Yeah, exactly. You partition up your data into a training data set and then a validation. Oh wait, yeah, this is your question. Go ahead.
And what do you have to say?
I was just going to say decrease the number of predictors you're using as much as you can, or like opt for a more simple model, because if you have 10 predictors and not a large amount of observations, the predictors are just going to explain the noise in your small data set.
Yeah, that is true. But if all of the predictors seem to make sense, then generally you go for some sort of dimensionality.
Okay.
Yeah. So yes, the right answer to that is, of course, just doing many-fold cross-validation.
Yeah.
Just train the model again and again on a bunch of data and then test again on a bunch of data. Of course, if you have the resources, just leave an on cross-validation so you have the most you can use out of your training data. Mm-hmm. But you want to make sure that you're not training your data on one kind of, you're not training your model on one kind of data that it gets so used to seeing that when it starts seeing real-world data that it starts messing up.
Because it fits to the noise in just your training set of data. Mm-hmm. Yeah. Right. So, time for one more, I think. What are hyperparameters and how do you approach tuning them? Yes.
So hyperparameters are parameters that you have to, like, it's dynamic, you can change it, and it takes like large range of values. Mm-hmm. So tuning is basically, you need to select the best parameter that fits the data set and that produces best model. And to do that, you usually use a cross-validation or a grid search.
Yes, grid search, that's what we were going for. Well done. And do you have some examples of parameters you might want to tune and why you tune them to begin with?
You mean examples?
Yeah.
Okay, for example, in neural network, you need to select a number of hidden layers, a number of nodes in the hidden layers, right?
Yes.
Yeah, so you just don't know how many for both cases most of the time. Yeah.
Yeah, exactly. Or like with random forest or one of the tree models, you might say number of branches, number of trees, tree or branch depth, things like that. Perfect. Good answer. All right, so now I think we can. You can do Avery already first.
Oh no. Please go ahead. Like BSTS would be more.
So the challenge here of doing this demonstration I didn't think about is the screen is extended and not mirrored. So I'm going to be working on the same screen as you guys. Let's see. So here's a good question. For this side of the room, does anyone know what language this is? Yes. Yeah, so this is R. So we're gonna bring in, I guess I don't really have time to explain this. I'll just kind of do it. We'll load some libraries, we'll set a seed so that we get the same result every time. So that's all good, we've got that. This is the Bayesian structural time series model I was talking about. So we're loading this data in and we're setting the names. So you can see what we've got is we've got a date, we've got sales, we've got our cost inflation, which is the inflation of the raw goods that we purchased. And then we have retail inflation, which is kind of across the country, what is the sales price inflation. So a couple economic things. And what we're trying to do here is we're trying to say, we launched a big program on 1/20, and did it have an impact?
Oh, you guys see in the back?
Not very well.
Go up.
That's
Just view it.
Oh yeah, there we go.
a little bit better?
Perfect.
All right, perfect. So take a look at this data here. We'll just run it through a quick plot, a little ggplot action. This is really hard. So like the mouse does the opposite of what I thought it said. We got this. We drag this up, and so now we can see a time series. The red bar is when we launched the program. And these are the different inflation metrics. And this is the store's behavior over time. So looking at this, we can say it looks like something happened, like their sales went up relative to where they usually are at that same point in years past. But we want to be a little bit more scientific than that. So what we will do from here is we're going to use this, I would say, masterpiece of an R library, which is the BSTS library and the causal impact library. So we start by just creating two vectors. One is the start and end date of the data we want to train on, and the second is the start and end date of when the program launched and how far into the future we want to measure. So we do that. Then right here, we create a response, which is what actually happened after we launched the program. So for those of you who are familiar with indexing, we're just taking the model data sales variable, and we're taking it where the date is greater than the first date of the post period. So that's what we will train our data on. Boom. Now we don't want our model to train on the data when it happened, because that would be confounding our experiment. So we take the same logic, we take everything after that post period one and we just delete it out of the data. So we can see that by pull up this ggplot again. So you see we had all of this data here, but we don't want our data to learn anything about that because we want to predict what would have happened had we not had the intervention. So we run that again. You can see now our data, that's all deleted out of there. And now here's where it gets really, really cool. So within this model, you can programmatically add states to your structural time series model. That's hence the structural part of it. So we're going to add a autoregressive model. And right now, I just randomly chose 3 lags, but you can definitely tune for what the best number of lags is. But we run that. Then it's super easy to then add a seasonal component. So right now we've got weekly data. So we're going to add monthly seasons into it. Oh, I skipped a line. Sorry. The Zoo package, for those of you who work with time series, is awesome. It's the hands down the best time series data structure that I've seen, and I like it so much I skipped over it. So now we've got our two states, and very easily we can pass this in. So we regress sales in this Bayesian structural time series to cost inflation and to retail inflation. And that run in real life. So these are Monte Carlo Markov chain simulations that are running right now. Don't worry about the graphics, that's fine. So in the real world, you would probably want more than 1,500, but in the sake of time, we're running it for that. Now we have this AR model. Somewhat simple model, but there's a lot going on under the hood there. So now we take this lift model, and we can just call a summary of the AR lift model. And we can see that this launch had for those of you who are familiar with statistical significance, this is essentially your 1 minus p. So there was a 98.8% chance that what we saw was not due to randomness. So the intervention actually had an impact. And then there's a bunch of other metrics I don't have time to get into, but you can take this and then we can plot, I'll just go right for AR lift model, and then we take the original series. Black demonstrations that I yes, no. But you can also use shorthand. No, something's going on with our plot. Yeah, there we go. All right. Just being finicky. All right. So now we can see the fit. Our model wasn't great because we didn't add that much to it, but the dotted line in the past is what we predicted, and then this vertical dotted line is when the intervention happened, and we're able to measure the probability of this solid line, which is the actuals, being that far from the dotted line mathematically. All right, so we are 2 minutes over. Kind of raced through that there. But now we can slide back here, and I don't know if we have time for questions if we are going to
check but until I tell you, you can keep on.
All right, perfect. Yeah, unfortunately, Chaitanya wasn't able to get into some really cool modeling, but so any questions at this point?
So how would you differentiate between customers, like especially in the season like Thanksgiving and all that, when they're buying, they're not consuming themselves, they're buying for their families, or like people are buying for communities.
Yeah.
So how do the models cater to that segmentation? You know, like the customer is not buying for their own consumption. Like if a mother or somebody from household is going, they're buying in bulk, bigger quantities, but not everything is being consumed by them.
That really speaks for two aspects. First is not all loyalty cards that we have are to customers. We also do aggregations on a household level. So, general assumption is that one person would be buying for their family, or so that accounts for that. And the second part is, of course, seasonality. So we not only have seasonality, especially in an industry like grocery retail. Seasonality is something that varies massively, not only throughout the year, but even if you see on a weekly basis, there are some days where you have higher sales compared to others. And Thanksgiving, for example, is one of those occasions where we're really pushing campaigns to make sure that we're driving sales. But at the same time, that event, which it's sort of a double-edged sword, because we also get a lot of noise in our data when we're really trying to do monitoring based on that. So, for example, and that's why Matt and I don't know BSTS as much very well, but Matt has really made me sort of a good fan of that, because in packages like that, you can really account for these holidays and account for the seasonality, or just take them off completely when you're working with them.
Yeah, it's actually. Yeah, there you go. So yeah, the package actually has functions, so you can do like random block holiday. If you guys are familiar with random block models, it feeds that impact into your actual time series. So you can do a lot to really dynamically build a powerful model and capture a lot of that variance.
There's one of the biggest problems that we face is trying to do seasonality.
Yeah, so you mentioned like sometimes you might prefer someone to have a higher understanding of a specific programming language as opposed to trying to scatter out the efforts between a bunch of different ones. So like using Python as an example, like what would you define that benchmark as, like the high level of understanding that you want? Because like a lot of to my understanding, a lot of the work with Python has to deal with different packages. So would you prefer someone to have a lot of experience with like packages like pandas or scikit-learn, like you said?
Yeah.
Or have someone have like a more fundamental understanding and then be able to like mold them once they're like there on the job?
Yeah. So so R is actually, I would say, generally more reliant on packages, and the reason is Python packages are broader. So, for example, in R, you'll be loading packages that do more specific things for everything that you do. But also, R is a data science tool out of the box. R was developed for mathematicians to use, whereas Python was not. Python was developed for computer scientists to use. So, but Python's like the pandas library is huge. Scikit-learn is huge. That said, you really can't do data science without a knowledge of pandas. You really can't do data science without a knowledge of, even if it's not scikit-learn, a data science library. Scikit-learn is the biggest one. But so to some questions that we get at, I usually ask for syntax. So one thing I do a lot is I say, it was one of the questions earlier, I say you have a column of daily sales, and then you have a customer ID and then a sales number. But by daily sales, I mean just the date. So December 1st, December 2nd, December 3rd. And you want to turn that into monthly sales and then scrub out anybody who has spent less than $100. So I'll ask that and I'll say, how do you do that in R? How do you do that in Python? How do you do that in SQL? Then I'll say, so like back to grid search. I'll say, give me the syntax, like what do you actually type into the console to implement grid search? So whether it's in scikit-learn or like H2O or Caret, one of those packages, like actually give me the syntax. So I get at some questions trying to understand the functional knowledge of language.
And like just to add to that, one thing that's very important is to, if you have like a good amount of knowledge in one particular language, it's not that easy to translate that into another. If you know R very well, then you will definitely find corresponding packages to the one that you're used to using in Python. So the learning curve isn't that much if you're doing one language well and going to the other. And so as long as you can solve problems, doesn't matter how you do that. As long as your work is reproducible.
Anything else? Perfect. Well, we definitely want to give a huge thank you to Bentley University for having us here. This has been really awesome. And thank you to Alex for coming up with this idea and making it all happen. It's definitely been really fun and interesting to be here talking with you guys. And as if you guys haven't noticed, we can talk about this for a long time. But no, this has been great. We really appreciate it.
Deck would be available.
We do have the deck, and that's not a problem. I have a problem with the fact that I have 70 people on my RSVP list, and I don't want to spam all of them with this. So I'm trying to figure out a way for you guys to be able to get this. We'll post it on the CMT page. We'll post a link to downloading it. I think that would be the best way, so that people that RSVP didn't show up are getting a deck they never asked for. So check the CMT website. We'll post the link.
Video would be available?
Sorry?
The recording would be available?
The recording, yes, of this whole talk is also available already. We live streamed it. So there's going to be also a recording.
It's already gone viral on YouTube.
Yes. And then I'll post the link to download the deck.
Great.
Thank you. Answers one variable.
Awesome. Hey, Sean. All right.
Okay, good. Yeah, that's very one of the ways that planning a planning service to actually.
Good talk, man.